This is video 1 on the 3 different types of proof, and we're going to look at how to show equal to each other. So here's an example of a question. You've been given a diagram, and you can see in this case you have 3a, 6b, and 5a minus b, and they represent vectors. So you might notice these questions, you might just be told, well, that vector there is just b, for example. But in this case, it's 6b. In this case, you actually have a subtraction of 5a minus b, and in this case, it's 3a. I can't label from inspection, I can't label any of the other sides. So for example, I can't say this is 6b because it doesn't look parallel and I've been told it's parallel. So in this case, the first thing I want to do is I'm going to express AB in terms of A and B. So AB is this vector here. Now obviously I can't go straight down AB, so instead I'm going to have to go this. The other way I might be able to go is to go that way along. Now obviously that's not possible because I don't know what AY is. So this vector here, we don't know what it is. So instead I'm going to go along there and then up there. So that's going to be negative 3a because I'm going to direction. Add 6b. And you can see that on the screen there. On the mark scheme it says 6b minus 3a, but it's the same thing, it's just different order. Commutative law applies here. X is on the point AB such that AX to XB is 1 to 2. That means that this is 1 over 3 and that's 2 over 3. So you always immediately label your fractions. by is 5a minus b, and that's already given to us up here, so we don't need to worry about that. Prove that, so this is where the proof question comes into action here. OX is equal to 2/5 of y. So all we need to do is really show that the left-hand side equals the right-hand side. So we can start with one of these first. So we're going to start with 2/5 of OY. How do we get from O to Y? So you need to write this out. So OY is equal to, well, we can't go this way because we don't know what that is. So instead we're going to have to go up and then left. So in other words, 6b, or let me do this properly. We're going to need to write the root down for the examiner. So it's going to be OB plus BY. Now OB is 6b. You can see that here. And then BY is going to be plus, now BY is just 5a minus b. When you simplify that, you can see you get, you get 2/5 of this. Now that's just the thing I've just worked out here. And then when you expand the brackets and simplify, you get your final answer. So you know that OY is 2a plus 2b. So we can label that on our diagram. It may be useful later. So OY is 2a plus 2b. Now we've done 2/5 of OY. What we now need to do is find what OX is. So OX is, how do we get from O to X? Well, I can't go directly from O to X because I don't have a vector given to me. So instead I'm going to go from O to A and then from A to X. So we can write this as OX equals OA plus AX. Now we know what OA is. OA is just 3a. Now AX is going to be 1/3 of AB. So I'm going to write 1/3 of, now AB, we actually know what AB is because we worked it out in part 1. So AB is given to us here. That's just 6b minus 3a or minus 3a plus 6b. So we can actually, I've just written it out here. So we have 3a, so that's OA, plus 1/3 of AB, and we know that AB is negative 3a plus 6b. After that, it's just a case of simplifying it. So you multiply everything by a third. So -3 times a third will be -1, and 6 times a third is going to be 2. So you get your answer here, 2a plus 2b. Now what you've actually just worked out is that both of these are parallel to each other, but also that they're the same size. So therefore you can say this is your final statement, which is essential. You have to say this to get the final mark. Therefore, OX equals 2/5 of OY. I think I've mentioned the therefore symbol. So therefore symbol is just 3 dots in a triangle formation. And that is how you can how you can prove something is equal. Now, on reflecting on this question, what you should realize is actually we haven't really done anything new. We've just combined skills that you already have. So going from one place to another, fractions, ratios, and then showing that one thing equals another. I'm not going to do any more examples of this type of proof because it is pretty much exactly as I've shown you here for all of these types of questions. So on the next video, I will show you how to prove things are parallel. So I'll see you in a bit.